All right, today we're going to break down one of the most powerful forces on Earth, the hurricane. But here's the twist. We're not going to look at it as just some random weather event. Nope, we're going to see it for what it really is, an engine. A structured, predictable, and unbelievably powerful atmospheric engine.
I know, that sounds totally backwards, right? We think of hurricanes as these massive wind machines, but believe it or not, the wind is one of the last things to show up to the party. The real story starts way, way quieter than that.
It all starts with something really simple, warm ocean water. It just sits there, quietly feeding all this energy up into the air. And that's the big idea for today. A hurricane is what happens when the atmosphere gets so overloaded with that energy that it just loses control. It's a chain reaction that, once it really gets going, is almost impossible to stop. So to really get this, we've got to shift our thinking. Let's stop calling it a storm for a minute and start calling it an engine. A natural, self-powering machine made out of nothing but air and water. This is it. This is our core definition. You need three things: heat, moisture, and rotation. Think of them as the three legs of a stool. You take any one of them away and the whole engine just sputters out and dies. But when you get all three in the same place at the same time, you get a perfect and perfectly destructive machine. Okay, so just like any engine, you need two things to get it started, right? You need fuel and you need a spark. Well, for a hurricane, it gets both of those from the exact same place, the warm tropical ocean. And here is rule number one. It's non-negotiable. 26.5 degrees Celsius, that's about 80 degrees Fahrenheit, the surface of the ocean has to be at least that warm. If it's any colder, the engine just won't turn over. It can't. This warm water, this is the fuel. So how does that heat in the water become fuel for the air? Well, it evaporates. It loads the air up with a ton of moisture. Now you got to think of every single water molecule as a tiny little battery, just packed with that heat energy, waiting for the right moment to be released. And this is the spark. That warm, moist air is light, it's buoyant, so it starts to rise. And when it does, it leaves behind a little patch of lower pressure. Well, nature can't stand a vacuum, so cooler, heavier air rushes in underneath to fill the gap. Then, that air gets warmed up by the ocean, it gets moist, and it rises too. You see the cycle? This constant loop is what builds your everyday thunderstorms, the little building blocks for our massive engine. But here's the thing. A bunch of thunderstorms, even really big ones, isn't a hurricane. It's just a chaotic mess. To become a true engine, all that chaos needs structure. It needs to get organized. And to do that, it needs a little nudge from the planet itself. I just love this line. It makes it sound like the Earth itself is an active player in this whole drama. Because really, it is. This is the moment a local weather event starts getting shaped by the literal spin of our world. And this is the secret sauce, the Coriolis effect. So as all that air tries to rush straight into the low-pressure spot, the Earth's rotation gives it a little nudge. In the northern hemisphere, it gets pushed to the right. And that little push is what gets the whole system to start spinning counterclockwise. It's what turns a chaotic blob of storms into an organized, rotating system. And let's be super clear about this. This is the absolute game changer. Without that spin from the Coriolis effect, you just have a big, messy rainstorm that would burn itself out pretty quick. The rotation is what gives it structure. It gives it focus. It's what allows it to become something so much more powerful. No spin, no hurricane. It is that simple. So we have all the parts. We've got the fuel from the warm water, we've got the spark from the thunderstorms, and now we have organized spin from the planet. The engine is primed and ready to roar to life, and the way it does that is through a really powerful feedback loop. Remember those little energy batteries we talked about? The water vapor? Well, as that moist air rockets up into the cold upper atmosphere, it condenses back into water droplets to make clouds. And when it does that, bam, all that stored heat is released. It's called latent heat, and it's basically like pouring jet fuel on the fire. It warms the air around it, making it even lighter and making it rise even faster. So all that rising air and released heat makes the low pressure area at the surface even lower. It basically turns into a super-powered vacuum cleaner, which then sucks in even more warm, moist air from the ocean's surface. And that new air rises, condenses, and releases even more heat, which makes the storm stronger still. You see the loop? The storm is now feeding itself. It's creating the very conditions it needs to get stronger and stronger and stronger. It's a runaway train. And this is the incredible result of that feedback loop. As it goes nuts, the pressure in the center absolutely plummets. To try and fill that void, the winds just accelerate like crazy. The whole system tightens up like a spinning ice skater pulling in their arms. And right there, in that moment, it's no longer just a storm. A hurricane is officially born. Now, a fully formed engine has this amazing structure. Right in the middle, you have the eye. It's this bizarrely calm, often sunny spot because air from way up high is getting sucked down into the center. But surrounding it is the eyewall, and that is pure chaos. That's where the feedback loop is the most vicious, with the strongest winds and the heaviest rain. It's a perfect ring of violence around a core of complete calm. Just an incredible paradox.
So when you boil it all down, what's the big takeaway? A hurricane isn't really about moving wind. That's just a side effect. At its heart, a hurricane is an energy-moving machine. It's nature's incredibly efficient way of grabbing a huge amount of heat from the tropical oceans and trying to move it somewhere else.
And that, right there, is also why they die. The second that engine moves over land or even just slightly cooler water, its fuel line is cut. The connection to that 26.5-degree water is gone. The engine runs out of gas, and that beautiful, terrifying, organized structure just falls apart.
And that really brings us to the final thought, doesn't it? We've established that a hurricane is, for all intents and purposes, a heat engine. It runs on warm ocean water. So the question we're all left with is pretty simple and pretty important. What happens to these incredibly powerful natural engines when we keep making their fuel source warmer?